On behalf of Kolkata Energy Education Park and West Bengal Renewable Energy Development Agency, we welcome you on board for an experience of a lifetime, a virtual voyage to the sun to which life on Earth owes its existence. Without solar energy, which we receive as light and heat on Earth, there would be no organic existence, no cloud, no rain, no vegetation. Nothing that makes our planet so fruitful and lovely. We are about to take you to the splendid star, which is 13 million times the size of the Earth. It's a journey of 149.6 million kilometers from this Earth. And finally, we'll reach the sun, right into the core, and unravel its mysteries. On our journey, we will visit other planets and satellites of the Sun family, that is, the Moon, Mars, Mercury, and Venus. Fasten your seatbelts, hold on to the armrests firmly during the flight.
This is your captain speaking. Cabin crew at your station, check all doors.
Done.
Check all safety measures.
Done.
Temperature outside.
19 degrees Celsius.
Weather.
Clear sunny sky with soft cotton clouds.
Humidity.
70%.
Attention cabin crew, ready for departure. We are now cruising over an archetypal city, a city powered by solar energy. The long stretches of solar panels extending for miles generate electrical energy for the entire city from solar power as a substitute to the traditional sources. The fuelless cars and non-polluting industries have given the city a fresh, picturesque look. Now we are 400 kilometers above the Earth. No air, no atmosphere, but gravitational pull is still present. To leave the Earth, we have to achieve a tremendous speed of 11.2 kilometers per second. That is the escape velocity. Astronauts, I'm sure that you have no doubt in your mind about this striking body. Yes, this is our nearest neighbor in space, the Moon, where some people have already set foot. The sky and the surroundings are pitch dark during the daytime because there is no atmosphere on the Moon. Look at our home planet, Earth. Now that's Mars, the planet next to the Earth. It is the most striking of all planets because of its distinct color. This is due to the presence of iron oxide in its soil. It was once thought that Mars had life on it. Because of canal-like lines, people assumed that there was agriculture. July 1976, Viking 1 and Viking 2 landed on Mars, and all dreams of life on the red planet were shattered. Canals turned out to be nothing more than craters or elongated ridges of mountains. Mars has no life, and other planets too are unlivable. So, we the Earthlings are the only life forms in the Sun family. Astronauts, do you see the black spot traveling across the Sun? It was once thought to be the 10th planet, but that was a misconception. That's not the 10th planet, not even a sunspot. That's the transit of Mercury. A lonely planet without any satellite, without atmosphere. It does not have any because of its poor size and mass. Over thousands of millions of years, space debris has smashed into the planet, leaving its surface covered with craters. These dusty powders happen to be the product of the smashed rocks. Oh, we escaped. Something nearly hit us. That was an asteroid, one of the various moving members in the solar system between the orbits of Mars and Jupiter. We are just a few seconds away from the Sun. Before that, let's take a look at the graphical view of the Sun. There are 3 different regions in the Sun's atmosphere: corona, chromosphere, and photosphere. But though these are conceptually separable, the regions merge and interact in reality. After we go through the atmosphere, we will run into the body of the Sun. This is divided into 3 zones: convective, radiative, and core. Of him is born light that excels all lights in destroying the unfriendly ogress of darkness. This is corona. Beautiful flares are coming out. We see these only during an eclipse because the very strong illumination of the photosphere hides them in broad daylight. As we head towards the center of the Sun, we are now passing the chromosphere. This red light is due to the emission of high amount of hydrogen. This is the brightest part of the Sun's atmosphere, the photosphere. The yellow color is due to the emission from the sodium that is present. The dark features of the photosphere are the sunspots, which we can see from the Earth also. They are the regions of slightly lower temperature. Is this darkness? No. Here the light is beyond the optical range of our eyes, so we have to turn on our ultraviolet camera to see the turbulence inside. Astronauts, this is the convective zone in the body of the Sun. The massive amount of helium has been converted from hydrogen releasing solar energy. It is thought that there was almost 100% of hydrogen at the birth time of the Sun. During 4.5 billion years of energy radiation after birth, almost 1/4 of that has been converted to helium already. We will now be entering the radiative zone and will switch on our X-ray camera for viewing. And now finally we are on the core of the Sun, the birthplace of solar energy. The matter here can no longer retain the ordered structures of atoms and molecules familiar to us. Everything here is what is called the fourth state of matter, plasma. Colossal energies of the stars, including our Sun, are sustained by a mechanism which is known as nuclear fusion. Let's take a microscopic view of the particles' motion here. Nuclear fusion is a process by which two nuclei fuse together to form another nucleus. The energy is released if and only if the mass of the two reacting nuclei is greater than the mass of the final product. In the Sun's core, hydrogen is converted to helium by nuclear fusion, releasing energy in the process. The energy travels from the core through radiative and convective zones to the photosphere, where it leaves the Sun in the form of heat and light. From the very center of the Sun, we now begin our return journey. And watch out for its movement in the reverse direction. Yes, it's the only planet which moves from east to west in the Sun family. Venus, one of the loveliest planets we can see from the Earth, sometimes at dawn and sometimes in the evening. Dense clouds of carbon dioxide restrict our vision of its landscape. We have to use the radar view to acquire knowledge of its land. Now see how big the comet is. The head, including the visible part called coma, may exceed in size the planet Jupiter. The dust-blackened nucleus may be 9 by 5 miles in size. Sometimes a comet extends many millions of kilometers into space. Now we are very close to our home planet Earth. But the speed at which we are traveling is too high for entry into the Earth's atmosphere. So, before landing on Earth, we have to orbit the Earth once more to retard the speed of our craft.
Cabin crew, stand by. We are approaching space station.
Welcome back to your home planet Earth. Cabin crew, open all doors.
Dear visitors, you were enjoying a virtual ride and watching a fiction film. Nobody from these terrestrial planets of the Sun family can reach the Sun anytime. Thank you and have a nice time.